Now, one of the things, and to give some of our audience something practical, that they can maybe play with, something that I experiment quite a bit to help the athletes modify their behavior, which I'm very big on constraint-led approach, right? Of coaching, rather than me telling them what to do, just like Nick Winkelman taught me, right? I'm going to let the drill do most of the coaching, right? By me reducing the level of possibilities of options that the athlete can select to solve the movement equation. So I'm going to narrow the possibility of movement options to make him kind of direct into one or two different type of solutions. So one of the things that I like to do when we're doing, I've been doing this with the second team, not with the first team right now. We've been doing some type of decelerations, is using different sizes of objects that they need to come in contact with, right? So, for example, if I want a very, very hard deceleration, I'm going to give you a cone that maybe is going to be the size of this cup. So that, and I'm going to have you place an object on top of that ball. So usually I use a cone and a tennis ball. So you have to come into full almost stop because you got to place the ball on top of the cone. So that's going to force a hard deceleration because it's also in a different type of deceleration because it's very low to the ground. So for you to get low to the ground for something that it's a few inches, you have to anticipate that very early on. You can't just wait to the last second and then just drop, right? So that forces that athlete to come in more gradual, anticipating, right, that deceleration. So that's one example. A different example will be, let's change that. What happens if I give you a cone that's going to be maybe the height of your knee, right? So we're talking about, like, I don't know, 30 inches of height, right? So that's going to be a little different because you don't have to get as shallow as deep into the flexion position. You can actually keep it a little more shallow, right? So is it going to be a little bit more of a choppier steps, a little bit more waiting to the last moment to stop compared to the lower one? So using those two cases, those scenarios, for me, it showcases a little different type of deceleration, where to make it more practical, and this is again most of I'm talking about empirical and experience and what I read and research, is that if I go into the lower type of setting of deceleration, it's going to be, let's just make it easy in the conversation, it's going to be very reliant on eccentric force production